Good morning, everybody. Welcome. It's a pleasure to be here. It's really my first in-person big conference after 2.5 years. So it feels like we are slowly moving in the right direction. Today, I'm going to talk about research that my team at MIT has been focusing on over the last couple of years. At MIT, I lead the data science lab. The data science lab, as you can see, is a partnership between MIT and about 25 companies, focusing on some of the most important challenges that these companies have by bringing together data, models, and algorithms. The data science lab is cross-industry. We have companies in oil and gas, retail, CPG, consumer packaged goods, government, airline, software companies, and we have a global footprint with partners in Europe, in North America, in Latin America, and in Asia. Examples of some of the research, some of the projects that we have done, and before I go into the examples, the data science lab at MIT includes PhD students, postdocs, and research scientists. The director of the lab is also here with me. It's Michelle Wu, who has been working in the lab for the last 4 years. So here are examples of some of the work that we have done in the last couple of years. A lot of work on supply chain resiliency that I'll talk about here. We started focusing on supply chain resiliency before it was popular. We started focusing on supply chain resiliency after events like the tsunami in Japan and the flood in Thailand. And the first implementation of our technology, think about what I'm describing here. This is technology coming from MIT, implemented by the Ford Motor Company. Of course, after the beginning of the pandemic, there was a flood of interest in our research in the area of supply chain resiliency. I'll talk about it, but the major step that we took in the middle of 2020 was a partnership with Accenture, a large contract between MIT and Accenture to scale the MIT technologies, the technologies that I will describe here. You can see there are other examples, but I will try to provide some insight into our approach for supply chain resiliency. A second area is on price optimization, both for online retailers and brick and mortar retailers. For online retailers like Groupon, like Zalando. Zalando is considered the largest online fashion retailer in Europe, like Kulala, which is a large online retailer in the US, as well as work for traditional retailers, Coppel being a large retailer in Mexico. Our technology optimizes their pricing on a week-to-week basis at the stores. And BTEC, which is a company in the Middle East with hundreds of stores in different countries. Work on personalized offering. And to describe this work, I'll give you an example. If you fly today from Paris to London, when you purchase your airline ticket, we are not involved. But once you purchase the airline ticket, our system, the MIT system, kicks in and offers you ancillary product. Priority boarding, car rental, hotel, and the offers that you will get may be different than the offers that I will get because the system learns about individual preference and provide customized, personalized offering based on what the system learns. Work in the area of inventory, transportation, procurement for companies like Home Depot and Mango, as well as for software companies like Blue Yonder that implemented some of our technology. Work in the area of online resource allocation. Before the pandemic, we did a lot of work with Alibaba and with IBM. Of course, the pandemic made a lot of impact on partnership in Asia, but we are still doing a lot of work with IBM in this space. And finally, work in the area of supply chain digitization with a number of companies. One example is AB InBev, where we, during the pandemic, use data to help them improve forecast by region, taking into account a change in consumer behavior because of the pandemic. Students in the lab, as I mentioned, are PhD students. You will see here example of partnership with industry, practical solution to a real-world problem. Our students get academic positions in the top universities in the world. Last 5 years, students on the faculty at Harvard, at Columbia, at Duke University, at Cornell, at Purdue, at NUS. And so this work that brings together academic research and practical impact is attractive not only to industry, but also to academic institutes. And so what I'm going to focus on, two examples. The first is the work that has attracted a lot of attention in the last couple of years around supply chain resiliency. I'll talk about the Ford implementation, but most importantly, I want to tell you a little bit about the history of the research in this area. And the second example, because we are here in Europe, I selected the implementation at Zalando. I want to show you how the research that we do at MIT is used on a day-to-day basis to price 1.5 million units of product, 1.5 million SKUs that Zalando has on its website. And finally, if we have time, I'll give you some, at least, of my learning working with companies in a variety of industries. And so the starting point is the work that we have done in supply chain resiliency. And if you look here at the slide, you see a number of Harvard Business Review articles. I'm not positioning this article on the slide to impress you with our ability to publish, but these papers really represent the evolution of our research in the area of supply chain resiliency. Accompanied or in parallel, we have technical papers about this work. As I mentioned, we started looking at supply chain resiliency after events like the tsunami in Japan and the flood in Thailand. At that time, most of the focus of supply chain executive was about efficiency and cost reduction using strategies like lean, offshoring, and outsourcing. But these same strategies that allow companies to dramatically cut costs significantly increase exposure to risk, and we saw the impact of these strategies during the tsunami in Japan and the flood in Thailand in 2011. These two events motivated the Ford Motor Company to collaborate with us in the area of supply chain resiliency. We developed a new way to frame, to model resiliency. You just immediately get the intuition that resiliency is a little bit different than efficiency and cost focus, because we understand how to measure cost. We understand how to measure the impact of a strategy on revenue. But what exactly, how do you measure the level of resiliency in a supply chain is not that straightforward. We implemented the technology at the Ford Motor Company. The Ford Motor Company was happy to talk about the implementation. And that's the paper that you see on the left-hand side. Between 2014, when the paper was published, and the beginning of the pandemic, I was knocking on many doors, trying to convince executives that they need to rethink their supply chain strategy. Resilience is as critical as efficiency. About 20 companies followed the research that we have done and implemented our technology. There was not a lot of interest. Everything changed at the beginning of the pandemic, but not necessarily in the way you think about this. In January of 2020, just think about the timeline. In January of 2020, the pandemic was hitting China. It was not in Europe, and it was not in North America. I started collecting data on what's happening in supply chain, in manufacturing in China in January of 2020, and I used the technologies that we developed 6 years earlier in the collaboration with Ford to try and understand what is the impact of the pandemic in China on supply chain in Europe and North America. And I very quickly wrote a paper, a 2-page paper that HBR was eager to publish. This paper appeared in February of 2020. This is the second paper that you see here, where we said, in mid-March, supply chain will stop, both in North America and in Europe. And that's exactly what happened. On March 17, newspapers around the world reported that the automotive industry was completely shutting down in Europe and in North America. But it was not only the automotive industry, it was industry by industry. We wrote in February, I submitted it at the beginning of February and said, mid-March, this is what will happen. 2 months later, I submitted and published a third paper in this sequence where we said we need stress tests for supply chain. And I borrowed that idea from the financial market. In financial market, after the 2008 crisis, the federal government in the US and government in Europe established stress tests that banks need to take their business through to identify potential problems. And we said specifically, we need to apply stress tests. And by the way, we said, we have stress tests. We know how to test different supply chain in industries, from semiconductor to food, to automotive, to consumer packaged good. And then the last paper that we published in this sequence was right after the beginning of the pandemic, of the war in Ukraine, highlighting the consequences of everything that is going on at the same time. COVID, US-China trade war, the war in Ukraine, on supply chain and on the economy in general. And so what I want to do is to talk a little bit about the framework that we develop for supply chain resiliency, and I will start from the bottom line. I'll start from the conclusion and then give you an insight about how we arrive at that conclusion. And the first observation that we make is that much like lean, resiliency is a philosophy. And if you believe that it's philosophy, it requires companies to find the right balance between efficiency, cost, resiliency, and business performance. And in order to do that, you need to build what I call a digital twin, basically a model representing your supply chain, and use some of the new KPIs that we developed in the collaboration with Ford, what I call time to recover, time to survive, and performance impact. And as you will see, these KPIs, this performance measure, allow us to identify hidden risk in supply chain. I will show you insight with one example, but in the last 2.5 years, we have implemented this in literally hundreds of companies. and we see the same insight over and over again. And so to describe the Ford case study, as you can imagine, Ford's supply chain is very complex. The initial implementation that we did was at the North America assembly facilities, but the supply chain supporting the North America assembly facilities is global. Ford has suppliers in North America, in Europe, in Asia. There are, just in tier 1, we are talking about 5,000 suppliers. There are multiple tiers of supply. There are 60,000 components that flow between different facilities until you arrive at the assembly facilities. This supply chain is responsible for 6 million cars annually. This was 2014. If this supply chain is disrupted, it's not just about Ford. It's about everybody in this ecosystem that is going to be disrupted. And the question is, where should Ford focus on in terms of mitigation strategies? Procurement had an answer. Procurement before us, based on intuition, based on past experience, focus on strategic suppliers. They said strategic suppliers are the riskiest suppliers for Ford. Who are the strategic suppliers? Strategic suppliers are suppliers where Ford invests huge amount of money every year. Total spend with these suppliers is very high. The leadership at Ford asked us, is this true, or maybe in addition to strategic suppliers, we need to look elsewhere. And so to answer that question, we started with supply chain mapping, right? A mapping of the supply chain that give us an insight about the different facilities, the flow of material, how much inventory, and so forth and so on. But it's difficult to understand where to focus on given limited time and limited resources. And so I want to introduce 3 concepts that we have applied, and they are very intuitive, but as you will see, extremely powerful. The first concept is what I call time to recover. What is time to recover? You look at a specific supplier, say for example, the chemical supplier, and you ask, what is the time it takes to recover to full functionality after a disruption? This supplier is telling us that its time to recover is 2 weeks. Why? Because today they provide us with chemical from a facility in China. If there is a disruption, they can switch production to another facility that the company has in Singapore. It takes 2 weeks. Now, collecting information about time to recover immediately raises 2 important questions. And if you are in the supply chain space, you immediately think about them. First, time to recover is scenario dependent. And there is a limit to our ability to generate all the relevant scenarios. The second, even more challenging, if I go to a supplier and try to understand information about time to recover, I'm very worried about what I get. Because the supplier is going to be optimistic. They are not going to tell us that their time to recover is 5 months, because they know it's going to be a big problem. So we need, in addition to the measure time to recover, we need something that is independent of scenario and that is independent of information given to us by suppliers. I'll come back to that in a couple of slides. But collecting information about time to recover allow me to calculate what I call performance impact. Performance impact is either financial or operational. Remember, the time to recover of the chemical supplier is 2 weeks. I remove this chemical supplier from the supply chain for 2 weeks, and I ask, what is the impact on Ford bottom line when this supplier is down for 2 weeks? What is the impact on lost profit? What is the impact on lost revenue? What is the impact on lost market share? Or what is the impact on lost production at the assembly facilities? Because I started with supply chain mapping, I can estimate this value, and in this illustrative example, the performance impact measured by looking at lost revenue is about $400 million. And so in this fashion, I can get an insight about the impact of a disruption anywhere in the supply chain on Ford bottom line. Now let's look at real data from the Ford system. So I'm going to show you screenshot that we took from the system implemented at Ford. Here is the first one. Bubble represents tier 1 suppliers. The Y coordinate is total spend at each one of the suppliers. To protect Ford confidential information, I am not showing you the amount, the value, how much dollars they spend, but you can see immediately here is a strategic supplier at the top. Here is another strategic supplier. Here is a third one. There are a few suppliers where Ford spend huge amount of money. On the X coordinate, I am showing you performance impact measured as lost profit during time to recover. You can see that strategic suppliers expose Ford to some performance impact, lost profit, but I would say it's moderate. The risky suppliers are all at the bottom right-hand side of this figure. I love this guy, the one at the most right-hand side of this figure. I love this guy because this supplier proved our point. This is a supplier that provides Ford with components that cost between 10 to 20 cents. But if supply is disrupted, you have to stop the production line. Now think about the following question. How many executives go to sleep and think these tiny suppliers that provide me with a component that costs 15 cents is my riskiest supplier? I can tell you, not at Ford. And not only not at Ford, not in most of the companies that I've collaborated with, that the lab collaborated with. And so the first insight is that in supply chain, risk is hidden in unexpected places. Let's go to the second insight, and again, a screenshot from the system implemented by Ford. Bubble represents tier 1 suppliers. You can see that they have tier 1 suppliers in North America, in Europe, and in Asia. The size of the bubble is proportional to risk exposure. The bigger the bubble, the larger the risk exposure. You can see risky suppliers are everywhere. They are in Asia, they are in North America, and they are in Europe. So insight 2 is be careful with what you read, at least in North America, in public media. There is a perception in North America that if you just move manufacturing closer to market demand, you are going to increase resiliency. This is not supported by our data. It may be important to move manufacturing and supply closer to market demand for many reasons. But on its own, it does not guarantee resiliency. And in some of the papers, we give other examples of what happened just in the last 2.5 years for domestic supply chain that proves the point that I'm just making here. And this point was made, as I mentioned, in 2014, the initial publication at Harvard Business Review. Remember now the challenge with time to recover. Time to recover is a concept that depends on scenario. Time to recover is a concept that requires information from supplier. I want a measure that is scenario independent. I want a measure that is independent of information from supplier. And that is what I call time to survive. What is time to survive? The idea behind time to survive, if you come from with operation research background, it's really the dual of time to recover. What is time to survive? I'm going to remove a facility from the supply chain, and I'm going to ask, how long can I meet supply with demand without that facility? It's clearly not zero, because a pipeline is full with inventory, but I can calculate this. And so again, you can see time to survive at Ford supply chain. On the X coordinate, I have time to survive in weeks. So on the left-hand side, you can see 1 day, 2 days, 3 days, 1 week, 8 days, 2 weeks, 10 weeks, 30 weeks, 50 weeks, and more than 50 weeks. Ford had components and parts whose time to survive is 60, 70, 80, 100 weeks. When you look at this figure, you realize immediately a challenge and an opportunity for Ford. The challenge is on the left-hand side. These are all the suppliers whose time to survive is very short, 1 day or 2 days. I don't care actually what they are telling me. I know they are very risky. But on the right-hand side, Ford has a big opportunity. Why? Because you have components for which your time to survive is 100 weeks. Why is it 100 weeks? Because Ford is just swinging in the dark and building a lot of inventory. Cutting inventory by 30% or 40% will still give Ford a very long time to survive, but will be able to cut Ford cost significantly. And that's why we say in Insight 3 that those facilities with short time to survive will lead to immediate disruption after an event, whereas those with long time to survive provide saving opportunities. Just quickly to highlight, Ford used our approach to change their risk mitigation strategies. If you look on the left, these are all the suppliers for which the performance impact is very low. It was more about tracking inventory and tracking supplier performance. At the top right-hand side, you have the strategic inventory, is the strategic suppliers. Here, Ford is in good position to require suppliers to have multiple facilities in different regions. But the challenge is at the bottom because here you have tiny suppliers. If you require this tiny supplier to have another facility in a different region, you may bankrupt the supplier. You may say, hey, let's build inventory. This is against the lean philosophy that Ford has. You may say, I can use dual sourcing, which will be great. The problem is these components are like commodities. Competition is on price and quality. There are very few suppliers competing in this market. If one of them is disrupted, the entire market will be disrupted. What we find in different implementation is that you need to think here out of the box. One solution that we have seen is a company redesign the product or redesign the component. Why? Because you want to standardize a component. If you can standardize a component, then you bring the supplier more volume. Bringing the supplier more volume position the company is a good situation to require that supplier to have another facility in a different location. And so let me summarize this part. Resiliency requires companies to understand financial impact. You need to realize that risk is hidden in unexpected places, and you need to look end-to-end at your supply chain. And there are tools that companies can use to identify the level of resiliency of their business. I just want to show you one statement from Ford, Executive VP for Product Development and Purchasing. He said 4 years after the technology was implemented, that Ford prided itself in having detailed information about each supplier and which one is susceptible to a disruption, including our concept of recovery time and financial impact. And he says, if you can do that analysis across your value chain, you can learn how to prioritize and manage a risk in your business. So that's my first example. This brings me to the second one, which is all about the implementation of online pricing strategy at Zalando. What I'm going to describe here is a project that lasted almost 3 years. We started in 2018, and the system, the MIT system that I'm going to describe, was implemented in mid-2021. So Zalando is considered, and many of you told me that you know the company well, is considered the largest online fashion retailer in Europe. The company sells men, women, and kids products. Last year, 2021, the company had 48 million active customers from 23 European countries. On their website, there are about 1.5 million SKUs. What is a SKU or article? If you look at the right-hand side, you can see basically the same design, but two different colors. For each design color combination, there are 4 different sizes. So the way Zalando define an article or a SKU, it's a unique color design, but multiple sizes. The company sells products from almost 6,000 brands. Think about the top fashion brand from Zara to H&M to Mango. All are selling the product on their website. Revenue last year was about $10 billion. And the company emphasizes aggressive discount, aggressive pricing. Company also emphasizes accessibility. For example, part of their strategy is to let customers return any products that they purchase at no cost within 3 months. And so they have very liberal policies, but this means that significant portion of what is purchased is returned to Zalando. There are many challenges pricing their product. First, every week the company generate a plan, a pricing plan for the next 40 weeks by country, by SKU, by week. And the reason they generate it for the next 40 weeks is because lead times are very long. If they realize, oh, there is an opportunity, they will buy more inventory. At the end of week 1, they rerun the model, eliminate the first week, add another week, and adjust prices accordingly. There are many requirements for each SKU. For each SKU, the company have a range of discounts that they consider, a max and a min. There are upper bounds on the switch in price from 1 week to another. You cannot either reduce the price or increase the price by more than a specific value. There is a long tail distribution of products. There are many products for which the number of units sold is very, very small. As a result, very difficult to predict customer demand. The company emphasizes customer experience. For example, they don't allow stock hedging. That is, if I have a unit of inventory, I cannot say, hey, next week I can sell it at a higher profit. If I have a unit of inventory and there is a unit of demand, you have to sell it today, right? That's stock hedging. The second one is related to the definition of SKU. Remember, SKU is multiple sizes. If there is one unit left, it's of specific size. It may be that it's different than the size that I want to purchase. How do I meet supply with demand when you have low level of inventory? Also, there are many global business constraints. What are the global business constraints? The global business constraints are set by the leadership, and they basically says target by country. Germany has a target of revenue, France has a target of revenue, and they have target by product category. And so this target makes the problem difficult because this target ties together the different SKUs. Does this make sense? And so all the business constraints are an input to our business goals, which is to optimize pricing in order to maximize profit while satisfying all business requirements. Before us, we are not the first to introduce data and analytics to Zalando. Before us, the company used a lot of historical data to generate a demand forecast using time series analysis, right? And they will generate a forecast by SKU, by country, by week, by discount. Then they say, we don't know how to optimize, taking into account the global business constraint, so we'll optimize one SKU at a time. You realize that because we are talking about profit, the objective is not linear, and so you need to use, in this case, they use gradient-based optimization algorithm. And then once they optimize by SKU, they ask sales and planners to adjust the prices to try and meet the target by country and target by category. Our process our objective was to automate the entire pricing process. So we use the same data, but we apply neural network to generate forecasts that understand the impact, for example, of low inventory or no inventory of one SKU on other SKUs. So the cross impact between products was a critical part of our model. Once we generate the demand forecast, then we optimize using a two-step process. First, we aggregate products into clusters of SKUs that behave in the same way. We replace each cluster by a dummy product that somehow represent all the product within the cluster. We solve a reduced problem. The problem decoupled into a problem by category. We solve a large-scale optimization problem for each one of the categories. You will see that we transfer this nonlinear objective into a mixed integer program with cutting plane. So let me say just a few words about the demand forecast. I'm going to use the time series model, which is what the company used before us, as my benchmark. And so every time they generated using time series analysis a forecast for the next 40 weeks, I am going to look at forecast error of the first week. I'm going to look at average seasonal error, and I'm going to look at the bias. You can see that the bias for the time series model was 14%. We, at the end, focus on transformer and neural network algorithms that allow us to include time series analysis into the model. It allows us to reduce the first week error relative to the benchmark by 30%. It allows us to reduce the seasonal error by 9% relative to the benchmark, and it allows to reduce the bias from 14% to 3%. The second step was the aggregated model. The aggregated model starts with unsupervised learning, cluster product into groups of SKUs that behave in the same way, replace all the SKUs within the same cluster by a dummy SKUs that somehow represent all the product in that cluster, solve an optimization problem on a reduced model. It allows us to achieve fast computing. It decomposes the problem into smaller problems by category. And most importantly, that the company did not expect, it provides amazing business insight. I'll talk about that in a second. So here is the original problem. These are the global business requirements. We replace product by dummy product using clustering techniques. This allows us, as you can see, to decouple the problem into a problem for each category. Because of the aggregated model, now I know for each country and category combination, what is the target by category, by country. So for category 1, I know the target in country 1. For category 1, I know the target in country 2, and so forth and so on. And now I solve a large-scale optimization problem for only one category at a time. How good this two-step approach in terms of accuracy of our result? So I'm going to show you a comparison between the benchmark. The benchmark means we solved the giant optimization problem on parallel computing. It took days and days to solve the problem to achieve discount for each product. And I'm going to compare it with our two-step approach that starts with aggregated model, decouple, and generate a discount by solving a large-scale problem for each category. You can see here I'm looking at two categories. One is women textile, the other one is women footwear. Blue represents the result from our two-step process. Orange represents the result from the benchmark. On the figure, you can see the distribution of discounts. So for example, for women textile, you can see that about 40% get no discount. And you can see that the distribution of discounts are identical between the benchmark and the aggregate, the two-step optimization model. Now you can say maybe the distribution is identical, but what about a specific SKU? Do you get exactly the same discount in the aggregated as in the benchmark? So I want to show you the second figure. Here I'm looking SKU by SKU at the difference between the discount generated by our aggregated model and the discount generated by the benchmark. You can see here that for almost all the product, more than 95% of the product, the difference is zero. Now you can, and this is true for both product category, you can say, okay, the distribution is the same, the discount is close to the same, but what about the objective function? You can see the value of the objective function in the two models are almost identical. In fact, the accuracy of this model is better than the accuracy of the data. And so the beauty of the aggregated model is that for the first time, the Zalando executive have a tool that allows them to plan better. Forget about solve better, but plan better. Why? Because when I solve the aggregated model, I all of a sudden understand what is the impact on my business of setting a specific target for a specific country. It allows them to find the right trade, or understand the trade-off between target, profit, and market share. And it allows them to understand the impact of less inventory or more inventory on business performance. Just quickly to highlight, the stock hedging was an important constraint that we needed to incorporate. Remember what stock hedging means. Stock hedging means that if I have inventory, I need to satisfy demand, even if next week it will be more profitable to leave the inventory today and satisfy. So we need to incorporate this into the model. The size availability was a little bit tricky. Why? Size availability means if I have very little inventory, say a 1 unit of inventory, if I have 1 unit of inventory, it's obviously of a specific size. It's not clear that this unit of inventory, this size is exactly what I want when I go on Zalando website, right? I may want a different. So how do I match supply with demand when inventory is low is very important. We basically use empirical data from Zalando to understand the relationship between the probability of matching supply with demand as a function of the amount of inventory and as a function of the number of sizes. The problem, of course, with this function, it's not linear. And so if you look at it here, it's not a linear function. We approximate this linear function with piecewise, this nonlinear function with piecewise linear method. And the only question is how many pieces you need. What we found through extensive analysis is that between 4 to 5 pieces give us an error between the true model and the approximated model of less than 2%. So let me just give you an insight about the implementation. After completing the development, we did a lot of offline testing. The first question that the company asked in the offline testing, are you achieving the target? Because remember, I'm splitting the problem into a two-step process. You can see there were 2 offline experimentation. In the first one, we had 50,000 SKUs, and you can see we achieve all the target. In the second one, we have almost more than 12,000, we achieve all the target. Then we were ready for experimentation in the field. Now, when you experiment in the field, it's possible that the model, our model, we say you achieve all the target. But if the forecast is wrong, while the model says you achieve all the target, in reality, you may not achieve the target. So we want to check whether we are achieving the target on the field with the sales that customers purchase from the company. We had multiple experimentation. Let me just show you. This is the control versus our algorithm. You can see in experiment 1, we achieve all the target. In experiment 2, we achieve all the target. In experiment 3, we violated slightly, but it was significantly better than the control. And then the company started believing in our technology. So let me just switch quickly. Come Black Friday of last year. For Zalando, Black Friday is not 1 day. For Zalando, Black Friday is 10 days. And so people at Zalando realized, hey, I don't need to focus on 40 weeks. Why don't I use the same method that was developed to generate a forecast for the next 10 days during Black Friday? Every day, I will use the optimization to optimize and spit out prices. Does this make sense? And so the key reason why they have started focusing on this is because during Black Friday, this is something I did not know, popular products disappear in hours. Remember, it's 10 days. Popular product may disappear in minutes or hours. But customer service is very important. Customer experience is very important for Zalando. So what you want to do is to use the demand forecast to identify products that are attractive when popular products are not there. Does this make sense? You want to identify substitutable product. If product A is not B, they know, oh, with high probability, customer who want product A will switch to product B. And so the system identifies this and price this product, the substitutable product, in an aggressive way to make them appear attractive to the customers or to motivate higher demand. You can see that this result, this is statement from Zalando, the result, significant improvement in customer satisfaction. They don't allow us to talk about impact on bottom line, but it was significant impact on bottom line. Let me just close by highlighting, here is a letter from Zalando VP of Product, Data, and Experience. He talks about when they started collaborating with the MIT Data Science Lab. He says, we implemented the system. You can see it here. I'm highlighting. This collaboration has made a considerable impact on our business. The core pricing algorithm central to this work has been launched on our platform in 2021, mid-2021. The pilot field experiment empirically validated that the optimization framework successfully steers the discount, the prices, towards the business target, and the model is integrated in the company weekly operation. Think about this. This is MIT. We are not Accenture. We are not McKinsey. But we are developing tools that I don't believe the consulting companies are able to necessarily develop. The new system automates the decision-making process for the Zalando online platform and demonstrates the power of integration of statistical learning and optimization to make, that's his word, not my word, a big impact on bottom line. Let me just conclude with 3 observations. The first is I started focusing on changing my research in 2011, where I realized I can still generate students who focus on supply chain, but the market is saturated. My student will have hard time finding just job in supply chain, academic job in supply chain. So I made 2 changes, one in resiliency, and the other one is data science. And I believe we need to emphasize data-driven research, both in teaching and in research. I also believe that if we emphasize data-driven research and teaching, it will allow us to develop new engineering and scientific methods that, what I say here, explain, predict, and change behavior. But, and that's the new focus, at least in my group, we need to understand the interaction between machine and human, between human and algorithm. And in that spirit, management science introduced a special issue, a call for special issue. The deadline is September 9 of this year, focusing on human-algorithm connection. We have people in the special issue in a variety of areas, from market design to operations to finance to marketing, all the way, obviously, to data science. If you are working in this area, I would highly recommend considering at least a special issue. Thank you very much.